video I'll be solving questions in your boost series. So this is your boost 2. So the first question was these many interactions were given and then you are asked to see which of the following is forbidden, right? Okay. So now the technique here is whenever you see leptons like this, first go and just check away your lepton number conservation, okay? So, and one important thing to remember is we need to check whether all the lepton numbers are conserved or not. For instance, you have to check your electron lepton number, muon lepton number, and if towns are there, then you have to check also your town lepton number. Okay. So here I see muon, electron, neutrinos with muon and electrons, right? Okay. So let me first check my L mu here. So for mu minus, it is 1, E minus it is 0, this is minus 1, right? This is minus, okay, this is plus 1 and this is nu E bar which is minus, okay, because it is 0. Because these are electrons and neutrino related to electrons, so electron anti-neutrino, my L mu is going to be 0 over there. And next let me check my E, Le, which is 0 here because it's a muon. For electron it is 1, this again is 0, and here it is, because it is electron anti-neutrino, it is minus 1, right? So this interaction looks okay for your lepton number conservation, right? So it is conserved. Now here if I check so I have muons here, so let me check my L mu. So L mu here it is 0, right? Because it's a meson. Here it is mu plus, and for mu plus it's minus 1, and for nu mu it is 1. Again here it is conserved, right? So here it is electrons, so it is 0 here, and for E plus it is minus 1 and it is plus 1. Again this is conserved. Let me check L mu here and Le here. My L mu here is 0, it is 1 here because it's a mu minus, so it is 0, E plus minus 1, E minus 1, 1. So what I see here is in the last interaction my lepton number is not conserved. Both of my electron lepton number and my muon lepton numbers are not conserved. So, but you all must remember to solve questions like this, you must remember what is the electron lepton number for electrons, right? For positrons, for electron neutrino and antineutrinos. All these numbers you should know. Then the question becomes very easy to solve. Okay. So moving on to next question, it asks me, this is a true or false statement. This question was given to check whether, to be sure about the conservation, strangeness conservation in different interactions. So we had your strong, right, electromagnetic, and your weak, and we know that in strong interaction strangeness is conserved, in electromagnetic it is conserved, whereas for weak interaction it is not conserved, right? So strangeness is conserved in weak interaction, weak and strong interaction. So the statement is false because in weak interaction strangeness is not conserved, right? So this is your question number 2. Okay. Now moving on to your question number 3, which asks you I and I3 of different particles, which is sigma plus, n and mu minus. Okay. So for these kind of questions where you are asked, here you are asked isospin and I3, but you could be asked your baryon number, right, or your other quantum numbers. So for that, what you need to know is you need to know your baryon octets and decouplets. If you know the quantum, the position of these particles, in your baryon octets and decouplets, then you will be more or less able to figure out the quantum numbers they have, right? Okay. For I and I3, for sigmas, okay. For sigmas, you have 3 particles in the family, right? It is sigma plus, sigma 0, sigma minus, right? So 3 particles, and the formula we should use here is m equals to 2I plus 1. So the multiplicity is 3, right? I'm talking about the sigma family. The multiplicity is 3. So 3 equals to 2I plus 1. So that gives me I equals to 1, right? So my I equals to 1 for my sigma plus, and I3, right? Now what is I3 for this? So I3 is, we do it in steps of 1, so 3 particles. So it is plus 1, 0 and minus 1. The particle with highest charge is given the highest I3 value, right? So because it's sigma plus, so it is plus 1, right? Okay. So now next is your neutrons, where we have to find your I and I3. Okay. The neutrons and protons, I mean nucleons are 2, right? Protons and neutrons. So the multiplicity is 2, which is given by 2I plus 1. So I equals to 2 minus 1, which is 1. So I is half and I3 is plus half and minus half. So the particle with highest charge is given plus half because a proton is charged. So I am giving it as plus half, and it's neutron, so it is minus half, right? Okay. Now for this, right, that means it's a muon. So muons are leptons. So we do not have any I and I3 for them, and I have explained in my when I was solving your boost 1 questions in your boost 1, I have explained why leptons, they do not have your isospin values. You can check that video. I'll link it in the description box. Okay, so this is your question number 3. Now you have the question number 4, which is you have to identify the type of interactions. This and it's K plus first. You all can here what you have to do is you have to identify the type of interaction, meaning whether it's strong, weak or electromagnetic. You all can go ahead and check different quantum numbers, but that will be a tedious process. The trick here is whenever you have nucleon interactions like this one, you just have protons and then the antiproton, right? And whenever you have nucleon meson interaction, that means proton and then pions, proton is a nucleon, right? And then you have your mesons, right? So whenever you have your nucleon and your nucleon meson interaction, the interaction is a strong interaction. Okay. Now let us move into the 5th question. So both the interactions in this question were your strong interactions. So the 5th question is, you have to check which whether the interaction is allowed or forbidden, and by, I mean, like, if at all it's forbidden, then by what interaction is forbidden. One thing you can see here, whenever you have a lepton, right, and you see your corresponding neutrinos as well, just go and check your lepton number conservation. For instance, here your L, okay, let me just do for Le. Le is here it is -1, 0, 0 and 0 because it's a muon, right? And I'm checking electron lepton number, and L mu is 0, 0 and it is mu plus, so it is -1. Okay. So I see here that my electron lepton number is not conserved. It is -1 this side and it is 0 on the other side. And my muon lepton number, it is 0 on this side and it is -1 on this side. So via lepton number conservation, this interaction is forbidden. Okay. Now another question The last question here is your proton and proton going to your K plus and your sigma plus, right? Okay. What we can check here is, because these are bosons, because these are your baryons, just go ahead and check your baryon number. B here is 1, right? For all the baryons, you have your baryon number as 1, and the antibaryons it is -1, and the particles which are not baryons or antibaryons, you have it, the baryon number is 0. So it's 1 here, it's 1 here. This particle is a meson, hence 0, and sigma is again a baryon, hence 1. So here delta B is not conserved, hence this interaction is forbidden by your baryon conservation number.